gravitational constant A of t, which equals negative 32 feet per second squared. So we need to use this equation to find the velocity equation. And how we do that is we take the antiderivative of the acceleration equation to find the velocity equation. So the antiderivative of negative 32 is negative 32t plus c. Since it's an indefinite integral, we have to add that constant. But we do know the initial velocity is 144, so we plug that into c. And with that, we get the final velocity equation, which is negative 32t plus 144 feet per second squared, or just feet per second. So this was part A, and part B asks us, when was the ball at rest, and what is happening at that point in time? So to find when the ball was at rest, we need to set the velocity equation equal to 0. So setting the velocity equation equal to 0, we get negative 32t plus 144 equals 0. And then we get t equals 144 over 32, which is simplified to 9 over 2, which is 4.5 seconds. And so it also asks what is happening at this point in time. So when the ball is at rest, when the velocity is at rest here, the ball is at its maximum height. So not when the velocity is at rest. When the velocity is 0, that's when the ball is at rest. So that's when the ball is turning points, like on a graph. This would be the maximum height. Part C asks, what was the maximum height of the ball? And so to find the maximum height of the ball, we need to find the position equation. And the position equation is equal to the antiderivative of the velocity equation. So it's the antiderivative of negative 32t plus 144 in respect to t. So negative 32t squared over 2 plus 144t plus c. But since we aren't given an initial height, we're told that the ball was hit on the ground, then the constant is just gone. It's just the final position equation is just negative 16t squared plus 144t. So now all we have to do to find the maximum height is to use the time at which the maximum height occurred, and we found that right here, 4.5 seconds. So we plug 4.5 seconds into the position equation, which eventually simplifies down to 324 feet.